Good morning, everyone. A storm surge module for IOR coastlines. Main goal is to shift how we handle coastal flooding. So instead of just reacting after a storm hits, we will use data to accurately map the risk beforehand. First, let us look at the threat. The Indian Ocean region is highly vulnerable to tropical cyclones, and the most destructive part of any cyclone is the storm surge, which is the massive wall of ocean water that gets pushed onto the land. So currently, our mapping of this threat is incomplete. While we do have data from past events, we lack a unified high-resolution map that can exactly show which areas in the coastlines are at most risk. So due to this, the coastal planners and emergency teams are currently operating under a major. Uh, they currently are operating under a major blind spot. So this highlights the need for a consistent physics-based framework. So my first contribution to this project is building an open source framework by using the schism or the semi-implicit cross-scale hydroscience integrated system model. I have ensured that this model is scalable and can be used again. Secondly, I have used an unstructured mesh to capture the complex coastlines of the IOR region. And third, I have built a Python based processing pipeline so that all the weather and ocean floor data sets can be properly ingested into the Schism model. So, this is the architecture. Step two is integrating the wind and pressure data for dynamic forcing and setting up the boundary conditions. Step three is simulating the model for the past cycle. And step four is validating those. So, these are the data sources that I have used for this project. First is the Jepco 2024 grid for building the mesh. Next is the ERA 5 reanalysis for wind and pressure data for dynamic forcing. And next is CMEMS global analysis data to set the boundary conditions for baseline sea level and currents. And finally, just UHSLC tide gauge data for validation. It becomes highly detailed. And generating this mesh was the most important part of this project, as without it, the physics for the further simulation would not have worked. So this is the step that I've. It involves testing the model for past cyclones that have occurred in the IR region, and then later checking the accuracy of the model by comparing it with the actual data from these cyclones. So these are the four steps for simulation. So this is the graph I expect will come after I compare the data from the model that I have simulated with the UHS data. And map on the right is to show how the final hazard map looks like. As you can see, the darker regions like or brown regions here show the regions which are the most vulnerable or which face the highest risk due to storm surges. So here I have shown how this project can be translated into real world action. So first, our model will generate the hazard atlas, which can show how the show where the storm surge water will go. Then, using it, we will overlay the data and population centers to assess the risk and vulnerability. And finally, using that assessment, city planners and engineers can use it for evacuation routes. To conclude, this project has helped me to develop a high resolution validated computer model that can accurately map how storm surges occur in Indian Ocean region. Moving forward, our next immediate step is multi-hazard. This involves combining the storm surge data that I got from this model and combining it with river flooding and sea water level rise to see how they interact with each other. And ultimately, our final to convert this hazard atlas into an operational early warning system so that we can prevent the damage that occurs due to storm surge before it happens. Thank you. Like currently, I am simulating a model for the entire Bay of Bengal region. That is variable depending on the because our coastlines are so intricate. I have used the that's why I use the flexible mesh so that uh, it changes the data as per the intricacies of the coastline, so that the entire coastline is captured in that. So like I have not exactly fixed a particular length for this data. Uh, so like currently I'm still in the validation process. I have not yet got the accuracy, but uh, I have simulated for one cycle and it is pretty accurate right now. So like some of the models that are currently being used are mainly used for like they mainly we use them like after the cyclone hits, then what we can use due to and there are predictive models also. But the advantage of this is that like this is the like those current models only focus on ocean flooding also. I want to include river flooding as well in that. This model is the best. Like I had searched it. So if I want to include compound flooding, that is include both ocean and river flooding, this model is best for that. Because only ocean flooding is not enough to accurately present how much flooding occurs during a cyclone. Because whenever cyclone occurs, there's it's followed by intense rainfall also, and due to that rainfall, rivers also get flooded, and so this model accurately captures both of these parameters.